What group of compounds provide most of the energy for living things? Some of this you might remember from biology or health or junior high life science. So hopefully some of this is starting to make a little bit more sense. Audrey.
Carbohydrates.
Good job. Number 2, what chemical process do plants use to produce glucose from carbon dioxide and water? Hopefully you already knew that before you read about it in your textbook. Maddie. Photosynthesis. And then what polysaccharide forms the cell walls of plants, gives plants and trees their rigid structure and an important part of our diet? Noah.
Cellulose.
Good job. And then also, can we digest cellulose though? Kendall. Okay. Which one?
No.
No. Why? Okay, Brecken can hear you better than I can. If you're closer to the mic, you're going to have to be quiet. But you're right that we're not cows. But why is it why do we eat it then, even though we can't digest it? We can't absorb nutrients from it. We just eat it. We just go around just gnawing on stuff we can't eat. Okay. Anyone know why? It has been a long time since we've had junior high. I know I've talked about this in junior high life science, but I mean that was 2 years ago for some of you. Or I talked about it last year in biology, but that was last year in biology. So does anyone remember why? Alright, so it basically cleans out your insides or your intestines, so it acts kind of like a bristle brush where it goes through and wipes out all of your villi and helps clean them out for you. Alright, you can go ahead and put that away and take out a piece of paper so we can write down stuff you don't know. Alright, do y'all want to play dice game or petty us or them? Petty us or them. Y'all just like to have words against each other. Alright, so Noah and Kendall, are you okay just having just the two of you over there? Or do you want to hijack a third person? You can kidnap a third person if you want.
I think she would kidnap.
Kidnap quickly.
Sounds weird.
Hijack a person quickly. Hijack a teammate.
Audrey.
Alright. Audrey has been hijacked.
Why won't you give me bad cards?
Ian,
Strategies.
keep your friends close. Keep your friends close and your enemies closer. Not that y'all are enemies. Just saying. Alright. So we'll start with the smaller team then. We will start with Maddie and Gavin. Alright. Let's go back and let's go over electrochemistry. Because the quiz is a little sad. And let's go over electrochemistry just a little bit more of it. Alright. So what do you call it whenever you're losing electrons? What is that?
Actually, oxidation.
Oxidation is correct. Alright. Your team or the other team? We're not doing the restart card right off the bat because that's lame. That's also lame because that was the second restart card. Negative 10. It's still pretty late, but at least it's not a 0. Alright, so Noah's team. Alright, Noah, what do you call the type of reactions whenever you're having the electrons transferred between the atoms? What do we call that type of reaction? Because it involves electricity. Okay, go ahead. There you go. Kendall's your backup.
What was the question?
Alright, here's your one repeat that I can't repeat over and over again. Alright, what do you call the type of reactions whenever you have the electrons are transferred between the atoms?
What does it start with?
R or O?
Oxidation reduction.
Oxidation reduction or a redox reaction. Negative 50. Alright, what do you call the type of solutions that can conduct an electric current? E, but everything in this chapter starts with E. I'll take that. Yeah, I'll take that. And so, electrolytic. You said it really slow. Maybe the question how you pronounced it. But yeah, electrolytic. Okay.
It's negative.
Positive. Positive. Alright. Audrey's turn. Alright, Audrey, what do you call the solutes? Kidnappy's turn. So, what do you call the solute in electrolytic solution? Electrolytes. Plus 10.
Okay.
Alright, what happens at the anode Oxidation or reduction?
Oxidation.
Oxidation. Alright, so there are 4 different types of electrochemical cells: electrolytic, voltaic, storage, and fuel cells. So those are the 4 different types of electrochemical cells. What type of electrochemical cell is you electrocute it and you cause the reaction to occur? There's electrolytic, voltaic, storage, or fuel. There's electrolytic, voltaic, storage, or fuel. Now, pick one. You have a 1 in 25 chance guessing, and then your partner will have a 1 in 3 chances of guessing it. Unless they want to guess the same thing you guessed. I mean, that's up to them.
Electrolytic.
What? Are you electrolytic, voltaic, storage, or fuel?
First one.
Electrolytic?
Yes.
Electrolytic is correct.
Us.
3-star. Correct here.
I knew.
Alright, Gavin, what is the process called whenever you electrocute it to cause that reaction to occur? No. What do you call that process whenever you want your solution to react? So you're going to run electricity to it, electricity through it to force it to occur.
Did start thinking it's not E.
No, it's an E.
Okay.
What do you call that process?
Electrolysis.
Electrolysis.
Awesome guess.
Yay.
Them.
Plus 100.
I knew there was something good.
Alright, so what do you call it whenever you use an electrolytic cell to form a thin coating of metal on another object?
Does it start with an E?
Yeah,
Electroplating.
electroplating. Plus 50. Alright, what is, alright, what is, of the electrochemical cells, what is the one to where it produces electricity? Okay, just went.
Is it 4 inches?
Yeah, between the electrolytic, voltaic, fuel, or storage? Voltaic. Negative 10. Alright, Andrew Sherman, what type of electrochemical cell is it to where it's designed to be recharged with electricity from an outside source? So you plug it into the wall. Storage. This is what your cell phone battery is as a side note. It's why it can be recharged. Them? Plus 10.
I said, oh, it's fine.
That was one of the best. That was one of the best consequences I ever gave for my summer care kids. Is you would take away their charging cord. It's fantastic. I've never seen kids freak out so much.
no.
That's awesome.
So funny. Well, I mean, they still have their cell phone or their iPad or their DS, and these are rich kids. I mean, they would have like multiple stuff. But you'd watch them slowly lose their mind in the afternoons.
If they're rich, they should have multiple chargers.
Yeah, some of them would think through that. They would actually bring multiple chargers for stuff. But I mean, again, you'd lose one, and then you'd lose probably the other one because these are kids that were used to getting their own way a lot. And so because of that, they would sometimes have a lot of consequences. Alright, I think it's back to Noah. Alright, Noah, what do you call the type of electrochemical cell whenever its reactants have to be replaced? Did you just go? I thought you just did storage. You're on the same team. Sorry, but fuel is correct. Alright, so back over to Matthew and Gavin. Alright, what's the most widely used type of voltaic cell? This is technically what your batteries are. And the battery is not the right term for them. Dry. Plus 25. Alright, Noah, we'll let your question count, so you or somebody else.
Did you look at it?
No. I like half saw it, but I don't know what I saw. I didn't pay attention.
Yeah.
Plus 10. Alright, what is technically 2 or more electrochemical cells connected to a single source of electricity? What do you call technically 2 or more electrochemical cells connected to a single source of electricity? B. Battery.
I'm a bad fan.
Negative 10. Okay, that's electrochemistry again. Alright, organic chemistry is a study of what?
Carbon.
Good job.
I'm a bad fan.
Should say
positive or negative, whatever it is.
Do you have any-
Alright, what do you call a compound that's made up of hydrogen and carbon? What do you call a molecule that's made up of hydrogen and carbon?
I thought I heard that, but I wasn't sure.
That's it.
Hydrocarbon.
Yep.
Then,
Oh,
Swap points.
I had a bad thing on that
but
one.
yeah,
How much do you have?
you have
How much do you have?
You have, you're swapping. You have
Tell
to
me,
tell.
Gavin.
negative 120.
We have positive 105.
Alright, if you have just single bonds, what type of hydrocarbon are you? Use Audrey's turn.
Something.
Yeah, remember there's alkanes, alkenes, alkynes. Which one?
So single one.
Single bond.
Alkane.
Alkane.
I have a good feeling about this.
Us.
Negative 25.
We're gonna beat y'all score.
Alright, so if I have a triple bond, is that an alkane, alkene, alkyne? Triple bond. Muted battery, so.
What?
Is it your turn?
Yeah, it is, because
It-
when I did
yeah.
hydrocarbons.
Charge the battery.
Okay.
Okay. It's the EY.
EY, alkane, alkene, alkyne. Alkene,
No.
alkyne. That's the only other one left. It says alkane. If you want to say alkane again, you can. Alkyne. Yes, it is the Y one.
You're gonna lose.
What? Busted. Alright, so obviously alkenes then is the double bond one. Alright, what do you call the hydrocarbons that are in a circle?
So let's see.
Start with C.
Said something weird yesterday. I don't know what I said yesterday. But it sounded like that.
Sound like what?
Thing I said yesterday.
That's very descriptive.
Can't help you.
And a C and an I and an R. Or a Y or something.
Okay, well you can't just throw out random letters and hope you're right. Right, Kendall, you back up. Alright, first person to raise your hands, right, Audrey has a chance to steal it back.
You better know it.
You both did no, don't listen, Audrey.
Well, I kinda know it.
Go. Alright, Gavin.
Cyclic.
Cyclic, yeah, of course cyclic. Some of your other.
Yeah, big.
Okay.
It's negative.
Yeah.
Negative 50.
Where's your
Alright,
Yeah,
so,
probably.
I'm just waiting for that sound reverse.
alright, so we'll say it's still Gavin's team since he stole it from y'all, so now it's their team's turn for real.
What he did fine.
Alright, so what is the group that has the delocalized electrons, Maddie? Okay, I'll leave it. Aromatic compounds. Alright, swap, team swap points.
Is there still negative 100?
Yes.
Isn't the, did someone want to get it already? Oh, no, they did not. Okay.
I was waiting for that. Alright, how much do you have again?
105.
You said the same.
Yeah.
Negative 185.
They just made it worse. Alright, what do you call the hydrocarbons where something's different about them, where they've lost an 8 so you stick in something else? I think it's Kendall's turn, since no one did lost his little question. What do you call the type of hydrocarbons whenever one or more hydrogen atoms have been replaced with a different atom or group? So something's weird about them. So instead of having H here, something else is there. S. Think of it like for like teachers, it's not your normal teacher, it's not a normal hydrocarbon, but we call it substitute. Substituted hydrocarbon.
I knew it. I could sense it. I knew it was gonna be negative.
Alright, what do we call the part that gets basically pulled off and put on? So what do we call that part that gets replaced over and over again? I think it's Maddie's turn. No, you just did aromatic hydrocarbons. Yeah, it's your turn. What do you call the the group of atoms capable of replacing a hydrogen. So it could be like halogen or a alcohol hydroxyl. It could be the COOH. What do we call that? To where you can shove it on a hydrocarbon. It starts with an F.
Yeah.
Yeah.
I have no clue.
All right, Maddie.
Is it Hebrews?
Yep.
What's the second?
G. Alright, so there's really, so I guess we can say, the purpose raise your hand in case you want to try to steal it back, Gavin, but I'm sorry. Alright, no, Gavin doesn't want to try it. This team gets one chance to steal?
Is it in a box?
No, it's outside the box.
Repeat the question.
Nope, alright, page 176, functional group. So the functional group, that's the part that gets
I know.
pushed on and pushed off.
No.
Alright. Functional group. Alright, there's no one new, we'll go back to Gavin's team. Alright, Gavin, what do we call it if a halogen takes the spot? So, I'm leaving myself. So, so this is a normal hydrocarbon, but let's say I add on a functional group and I add on OH, well I said a halogen, so we'll say Cl or chlorine. So, what do we call it if it's a halogen added on? You can be closer, Maddie.
Oh no, it has halogen or something. I know.
Alright, all of these have single bonds, so that should help you out.
Halogen.
I think I might know it.
That's kind of pretty. Okay, I'll take it.
No.
I'll take
I
it,
might
but
know
it's
it.
new.
I might know
You
it.
may say it just for fun, Noah.
Is it like halogenic?
Okay, not quite. Alright, haloalkanes, because it's all single bonds, and so there's a halogen in the front. So haloalkanes, that's the name for them. Okay. Now you got close. Plus 25. Sorry, I looked. Alright, what do we call it whenever we add on the OH functional group, or the hydroxyl functional group? I think this is Audrey's turn? Here, Audrey, what do we call it? Alcohol.
Give it to us.
No.
No. No.
Them?
No. No.
It's her, she gets to choose.
No.
Negative 25. I think you're kidnapping you trying to sabotage you.
Yeah.
Still
No.
two restarts in there. Okay.
There, I'm not telling you.
Exactly.
I remember us getting a single one.
Good. Thank you,
Alright.
Star. Did you reach your last score?
Alright,
No.
What
that
if
was in the
it-
600s. What do you think?
looks like this. What type? So what do we call it whenever we add on the COOH functional group? Y'all just went for alcohol, so it's Maddie's turn.
What's the second?
C. C.
What's the second? Is there a second word?
Yep, starts with an A.
That's not very helpful.
No.
I have no idea.
Alright. Does this team want to try to steal?
Hmm.
Oh, you're the backup, Gavin. I'm sorry, I'm mistaken.
Starts with a C and A.
Mm-hmm.
I don't remember anything but the abbreviations.
Alright, anyone else want to guess? Alright, carboxylic acid. That's the name for them. So
What?
carboxylic acid. We'll go over it again. I think I went kind of fast through them yesterday, but I was watching the time. So we'll go through them again. Alright, carboxylic acid. Alright, what do we call it whenever you drop an H and then you add on the rest of the carbon chain? What do we call that? So it's COO. Back to Maddie and Gavin's team since nobody knew it. E.
Ooh.
Alright, Gavin's the backup. You think that's the only one you memorized?
She said it earlier.
I know it. I think.
Esther.
Good job, it is Esther.
No.
Alright, there are 4 cards left at a side note.
Or what?
Us.
4 cards left.
Us.
You sure?
No.
Sure.
No. No. I'm like this. Perfect.
Okay, back over to that team. Alright. So, if it has, I'm gonna go over these again, I wanna make sure y'all got them. Alright, so if it has a halogen, like fluorine, what do we call it? If it has a halogen added to it. Which, is it your turn?
No, I think it's mine.
No, you tried to sabotage it potentially. Okay, so,
Did they say it earlier?
someone said it earlier, I already asked this.
Haloalkaline or something.
Alright, what do you call a molecule that has all just single bonds in the hydrocarbons?
Oh,
Al something else. Alkane.
Okay, so put halo in front of it.
Haloalkane.
There you go.
Us.
Looks kind of like Halo, so just picture a bunch of single bonds, like all playing Halo all together. So there you go. Try to remember. Okay.
Yeah, us.
Sign reverse, you know, positive or negative, whatever it is.
Hey, that's better than what they would have done. They would have done like positive 200 something.
Okay. Over here. Alright, what do we call it if, that was my shoulder. Alright, if it is bonded like this, so it has a COOH. I just said it.
I'm trying not to look at that. Yeah, carbo,
Which one?
weird X thingy.
You can't go carbo weird X. If you need to look at it.
The carbo.
Doesn't
Acid. Oh wait, yeah.
Okay.
Carbo.
Carboxylic
Yeah, that's
acid.
it.
Okay. You or somebody else.
Us.
Us.
No! No!
Restart.
No!
Alright.
We're-
Back
they
over
already
to
got this
Noah's
one.
team. Alright, Noah, what do we
One
call it
left.
if it has the COO?
Esther.
It is an ester.
Us.
Plus 25? I don't know if that helps you out.
Wait, we got the other restart?
Yeah, it was in there. I dug through it to see. I mean, yeah, it's already gone through.
How did you win?
Alright, so look over on page 177. I think I went through this part a little bit too fast yesterday trying to get through it. I think I might have taught it too quick. So make a note, a halogen has what? What's the functional group for a haloalkane? Kindle. What's the functional part? What's the part that gets added onto it? Okay, you're right, it has single bonds because it's haloalkane, but what's getting plugged onto it instead of the hydrogen? A halogen, good job, these are examples for it. So chloromethane, iodomethane, tetrachloromethane, just saying, okay, this one has 4 chlorines bonded around it. Alright, so methanol, so remember, methane is 1 carbon and 4 hydrogens, so the ending gets changed to ol, so that way we're saying it has an alcohol group. Alright, carboxylic acids. So this one is called ethanoic acid. So why do we have F in front of this one? Anyone remember?
One.
Alright, why do we have F?
I heard F.
Sorry,
I
F.
was like, what?
F. Why do we have F in front of this one?
2 carbons.
Yeah, so this one is ethanoic acid. Sometimes you hear it called acetic acid. That's another common name for it. Because there are 2 carbons here, so this is a carboxylic acid. Alright, so it has the C, double bond to the O, and then to the OH down here. Alright, anyone have any questions about these so far? Alright, the esters are very close, but instead of having the COH, like a carboxylic acid, they drop the second H, and then they add on another carbon chain to it. Alright, so those are an ester group for it. So the first word, it ends in the ol because it's talking about the root down here. So this one is methyl. Alright, so why do we call this one meth? Still not drugs. Why is it called meth? Audrey. Because there's 1. So methyl and then 2 high and then 2, oh, I'm looking at this one down here. Methyl for this one is a little bit weird because this one is oil wintergreen. So methyl 2-hydroxybenzoate. So it's referring to the fact it has these delocalized electrons down here. So methyl butane bonds. Remember, what do you call a hydrocarbon that has just the single bonds, Kendall? Alkane. So for this one, it's butanoate is how a lot of people say it. So sometimes they will say it fast. Butanoate is how they'll say it quickly for it. But butanoate is how they're saying it. So remember, what does the but refer to? None. What? 4. So that's where this name's coming from. So the first part has the ol ending referring to the little chain down here. And then but refers to the 4. Ane refers to its still single bonds. And then O8 refers to the fact that it's an ester group. So methyl butane O8 is how they'll say it. Alright. Anyone have any questions about that? I think I went too quick through it yesterday. Alright. So we talked about soaps yesterday. Why is a soap important? What does it do that makes it unique? It makes it valuable, or at least useful for us. Kendall. So, because remember, what's the general rule that says only polar dissolves in polar and non-polar dissolves in non-polar? 100. Right? Alright, it's the general idea of light dissolves light, with the idea of, okay, it has to be polar to polar and non-polar to non-polar. So, with my little happy soap molecule that I'm still proud of. So, oil is polar or non-polar? Gavin?
Which part of it?
Oil, polar or non-polar?
Oil, I think so.
Oil.
It's polar. Wait, yeah, non-polar.
Non-polar. Water. Stuck now. Polar or non-polar? Polar. So will oil mix in water? No. So that's how come the soap molecule is unique and helps you to get the the grease out of it, because the soap will basically stick to it. Now I color coded it today, so that way the oil is non-polar, and I have the non-polar end that's attracted to it, and then the polar end sticks off, and so the water can come by and grab the polar end and help drag it away. So that's why soap is useful, because it's like a bridge to where it can connect polar and non-polar. Stop judging me, Gavin. Alright, so hard water. This is water containing ions of the iron, magnesium, and calcium. True salts will make kind of this scrub substance with it, so it makes kind of like a chalky substance, and so we don't like that. So technically, our soap molecules today are types of detergents. Alright, I think that's it. If you make a note, a soap is technically a salt containing a carboxylate ion with an alkali metal. Alright, let's try to do that yesterday. So polymers today. Polymers are basically long chains. We associate these with plastics and synthetic fibers. So we can actually make these. So what they'll do is they'll take ethene. So if it's ethene, what does the F mean in ethene? What does the F mean? Audrey. I drew a blank of what your name was. I don't know what I was going to call you, but it wasn't Audrey. I think it was going to be like Effie or something like that. I'm not sure where that was even coming from. Alright. 2. Alright, what does the ene refer to? Maddie. Maddie was almost Madeline earlier. I'm not sure why. That was a bad day.
It means it's got 2.
It has a double bond. So this is an example of ethene. So there's 2 carbons and it has a double bond. What scientists will do is they'll take that double bond and they'll break it. Now keep in mind, how many valence electrons does carbon start off with? Anyone remember? Because my periodic table is still pulled up.
Yeah.
Very good guess, but no.
No, wait, no.
1,
4.
2.
Yeah,
4. So it has 4. So because of that, it needs 4 single bonds. So if it breaks that double bond, it's going to have to form up an extra single bond to satisfy it. So that's what it's showing you down here, that if you break that double bond, each carbon's not happy anymore. But you can hook up a long chain of these. Now, technically they're more of like zigzaggy like this, but we just draw them as a single line because that's easier to draw for it. So that's what this is turning into. So polyethylene, we still name it off what it started as. So even though it doesn't have just the double bonds anymore, it's all single bonds, and there's way more than just 2 carbons, we say, okay, it originally was this. So that's why it's polyethylene. It's a bunch of these broken ethene molecules over and over and over and over again. Alright, Make a note that a polymer is a organic molecule. This is made up of a much smaller parts. So the monomers, those are the little individual units that are put together. So we undergo this with the process of polymerization. So at least all of the terms kind of make sense. So monomers, or mono, you think of it means one. So monomers, they make up a long chain. We call the long chain a polymer, and then it's polymerization. Polymerization is how your book says it. Sometimes I hear it another way as well, but polymerization is how your book pronounces it. Alright, anyone have any questions about this? Alright, oops, too far. So, your book talks about common polymers in the next page. Your book talks about polyester. This is made up of repeated ester units. Anyone know what is polyester typically in? I guess? Yeah, so if you look on the back of your tag, not right this second, but if you look at like the back of your tag, you'll probably say like 90% cotton, 10% polyester. So polyester doesn't wrinkle as easily, and it's not nearly as hot as just pure cotton, and it's not as itchy. That's come, a lot of your clothes are polyester on the inside of them. Polyvinyl chloride, we use that one as a type of plastic. Polystyrene, that's used for plastic models and many other molded articles. Polyamide, that's used, that one's common name is nylon. It's used in hosiery to fishing lines, used in a bunch of stuff. Anyone know what hosiery is? That's a name for something. We don't use this term a lot, or this type of clothing a lot. Anyone know? It's not like a garden hose. It sounds like hosiery, but that's not it. It's an article of clothing. Alright, it's kind of like those fancy stockings that ladies wear, so that's the technical name for them, is hosiery. Alright, so your book points out another type of nylon is 5 times as strong as steel by weight. Your question, Noah? Okay, if you're not distracted, because Bracken can hear you much better than I can, because you're closer to the mic. Alright, your book points out one of the other kind of major ones is polytetrafluoroethylene. Now this one is used in cookware, valves, and bearings. Alright, your book has a picture of what polytetrafluoroethylene looks like. Alright, if it's called polytetrafluoroethylene, break it down into the parts over what it means. So, poly just means many. What does tetrafluora refer to? Four? How many? Like four of what? Fluorine. So polytetrafluoroethylene. So, what does the F refer to again? Two carbons, and then that one is ethylene. So because of that, how many bonds are in it then? Two. So the name will tell you all the information about it. Your book has it as the third one in that box. So that's polytetrafluoroethylene. So the names will tell the scientist what's it made of. Alright, anyone have any questions about polymers? Alright. Biochemistry. This is one of my favorite sections in the book because I like biology, so I get to kind of go back and relive biology a little bit. So this is my favorite section. Some of you might be thinking, oh, no, we're getting back into this. Some of you might be looking at the picture and going, oh, no, I remember this a little bit, and I don't want to, but it's okay. This is a slightly easier version because it's not biology. And I know it's not biology, so I'm not going to be as crazy about it as I was previously. Next year, some of you next year, ready? Alright, but for right now, we don't want to go there. So, just think over at my biology people. Sorry, biology people. So, we talk about the different parts of the cell. So, the recycling plant center, or the lysosome. Hopefully, this kind of jogs your memory, and hopefully you're thinking trauma and sadness. Coronavirus, I'm sorry. But yeah, so the power plant, or the mitochondrion, the food storage, or the vacuoles, so the Golgi apparatus, mitochondrion again, control center. Now, the nucleus is the control center. Anyone remember what's stored on the inside of the nucleus that tells your body all of your instructions? Let me talk about this in junior high as well. I know that was a long time. Okay. Gavin, you acted like you wanted to say. Okay, so what's on the inside of the nucleus that tells your body and gives all the information? It's written in. Okay, Gavin's raising his hand again.
Guessing it's the control center.
Okay, but why? Like, what's on the inside of it that tells your cell what to do? Okay. What?
Brain.
Okay, you don't have a brain on the inside of every single cell. You have basically a giant book. It's a giant coding information that says, hey, this is how everything's supposed to be on the inside of it. This giant library, basically. So it's stored, what? It's 3 letters that we use to name it, okay? DNA. So DNA is stored on the inside of your nucleus to tell all of your characteristics. Your waste disposals or your vacuums again down here, cytoplasm, so your microtubules. So these are all the insides of your cells. So your book's pointing out, okay, that your cells are having chemical reactions. That's how come we're studying it right now with biochemistry. So this is biochemistry. What type of chemistry is it? What are we studying? No.
I forgot.
It's what?
What?
No, what are we studying? We're studying biochemistry. Life, because bio means life. So this is life chemistry for it. So your book points out that, okay, you have a lot of chemical processes on the inside of your cell, and then also your cells will use the nutrients that you eat and other things in order to carry on the daily life processes. I know we use this term in junior high, but again, that was forever ago for some of you. Does anyone remember what you call the sum of life's chemical processes? Starts with an M. That was a long time ago. No, it's okay.
Wait,
Starts with an M. The sum of all life chemicals processes. Metabolism.
Yo.
Good job, Noah. So yeah, when your cells carry on metabolism over and over again. You're good, Noah. And so this one is where your body's carrying on those life processes. So in these things like water, nutrients, carbohydrates, in order for all your chemical processes to occur. What happens if your cell can't get all the nutrients or water that it needs? What's going to happen? Noah? Death. So yes, your cells need them. Alright, so your book points out there are 4 primary types of organic compounds: carbohydrates, lipids, proteins, and nucleic acids. That one might seem like a new one to you, so that one's a little bit different for it. So your book points out that that they're still studying to figure out, okay, how can we help your body to stay alive so you don't have death over and over again. Alright, biochemistry is the study of the chemistry of living things. Alright, your book's just talking about carbohydrates first off. Alright, beginning back to junior high or health for some of you. Alright, what is a carbohydrate? What's an example of it? Audrey.
Sugar.
Right, that's a good one. Anyone else think of another one? Alright, so if you're gonna eat carbohydrate, typically you just don't get like a whole cup of sugar and start eating. You might. Please don't. That's not healthy for you. But what are you eating typically if you're gonna get carbohydrates? Or carbs? What did you say? Okay, we're still back to sugar. But yes, bread is another version of it. So this is whenever you have a carbohydrate, it's made of typically carbon, hydrogen, and oxygen. These are all examples of carbohydrates. This is what glucose looks like. And then this is what sucrose looks like. This is regular table sugar. If you are going to go get a whole cup of table sugar and just start gnawing away, that's gross. As a side note, don't do that. It's nasty. You'll get sick typically from doing that. So sucrose, make a note for that one. Now sucrose is made up of 2 of them. Glucose is just 1 molecule. Now we call these simple sugars. Anyone think they remember why we call these sugars? I'm sorry, I wrote that wrong. Alright, so why do we call them simple sugars as opposed to complex sugars? They don't have a what? Alright, so this one is a long chain of them, but you're right that the simple sugars, typically they're only made up of these couple of rings, and that's pretty much it for it. So, your book points out the small carbohydrates, these contain up to about 10 rings. The monosaccharides only have 1 ring, so a glucose, I'm worried that I knock this off my desk in a second. This is considered a monosaccharide because it's 1 ring. This is considered a disaccharide, or they would call it a polysaccharide. So, your book points out fructose is another example of a monosaccharide. Alright, what is the process that makes glucose? You cannot make glucose. So what is the process whereby glucose is made? Photosynthesis. Alright, what carries on photosynthesis? Light just carries on photosynthesis. I can go out and I'll just pick up sugar off the ground from light. Plants carry on photosynthesis. So we'll go over to the next page. Alright, so these are, so your book has a reaction to make glucose. You don't have to know the reaction, that's okay. But it's super important. That's why plants are able to make glucose for all the other everything else pretty much on the planet. There are a couple of exceptions, but what do we consider plants, since they're kind of the starting point for food, what do we consider them, biology people? Thinking about it with ecosystems. Or like science people, if you remember from a couple years ago.
What was the question?
What do you call, okay, producers are the first energy level, or the first trophic level, or a producer, because they're starting off that point with producing their own food. Now a consumer, not someone that has to go out and eat something. So, Kindle, are you a producer or a consumer?
Well,
You can just go stand outside in the sun and be like, feed me. And you can make your own food. You need to go to the doctor. I want to know how you do that. Because most other humans cannot. Most,
Oh.
I would say if you can, you're the one exception. All the other humans can't. But yeah, we have to go out and eat something. If you try that, Kendall, you probably won't be able to do it for too long until you go on to meet Jesus. So you have to eat something. Your body's not designed to make its own food. Your body will start to cannibalize your own self as a side note. That's the reason why your muscles will start to deteriorate, because your body literally says that's protein and starts taking it out of your body in order to keep your basic functions alive. So, you make a note though that a disaccharide, this is like table sugar where it's two of them hooked together. I said polysaccharide by accident a minute ago. So make sure that sucrose is a disaccharide. Di refers to two. Alright, polysaccharide we refer to these large chains of sugar. So we commonly call these, some of them we just call them starch. So what would be an example of a starch and that you eat? Not like starch like that you use to put on clothes to iron them. Like what do you use whenever you're gonna eat it?
Corn.
Okay, corn's a good example. Anyone else know? What's the other one? Alright, Kendall, was that hand raised? Anyone else think they know? Alright, bread's an example of starch. Rice is an example of starch. I was going to say noodles, but I mean that works for it. So, noodles is an example of starch. Things like that are all examples for it. So, your book points out that starch is typically better for you than just sugar or candy bars. Why, Maddie? What? Alright, because what do you think is easier for your body to use right away? The single chains of glucose and fructose, or a long chain that has to be broken apart? The little one. So this is basically your body can take all of this and burn through it super fast. That's the reason why if you get a sugar rush, you get a ton of energy, but then you can also get a sugar crash later on because your body's burned through all of it too quick. If you eat something like potatoes or noodles or bread, your body has to work and break it into pieces as it uses it, so it makes your body slow down and use it for a longer period, as opposed to getting it all at once. So that's how come doctors and people tell you want to eat starch as opposed to just sugar. Because even though your body can use just sugar, just candy bars, it's too much all at once. So your book points again that some common polysaccharides used for food storages are starches found in plants and glucogen found in animals and people. Anyone remember, what is the hormone that takes sugar into your blood and stores it as glucogen?
What's
I. Insulin. And so that's why if you have someone, or if you know someone that has diabetes, that if they have something's wrong with their blood sugar, it has to be to where they might have to take insulin because there's too much sugar in their blood. And so the insulin will tell them, hey, you need to store the sugar as glucogen. Now it's not too much in your blood all at once. That's the reason why people have to take insulin or help regulate it. Alright. You've been talking about another important polysaccharide is cellulose. This one is one of the largest polysaccharides. Now we can't break this one down, but we still use it. Does anyone know what's the common name for cellulose called? Typically, we don't say, hey, did you eat cellulose today? We use a different term. F. No. What? Fiber. So instead of saying cellulose, we'll say typically fiber or roughage. Now you might have a parent or a grandparent that has to watch to see how much fiber they're eating, typically because they're worried about getting colon cancer. That's the major one you're worried about for it. But it's to help keep your intestines clean. So that's what you want to eat a little bit of fiber, not all of it, because your body can't digest fiber. So if you ate nothing but fiber, what would happen, Maddie? Why? Okay, well, your body can't digest it, so what would happen if you just ate that over and over and over again? Yes, why? Your body basically passes it on through, so you're not getting any nutrients from it. So basically, you'll starve to death, even though you're eating fiber. Your body can't use that for anything. It's just to help clean out the insides for it. All right. Anyone have any questions about this? All right. Okay. I don't know if I want to start with this or not yet. We'll go ahead and we'll stop there. All right. What is due tomorrow? Investigation plan is the second draft, so it doesn't have to be perfect yet. But bring it, and we're gonna go over kind of like a workshop tomorrow. Making a stomach and the trip is and the have the paper. Alright. So thinking back over it, what is the study of living things? Well, sorry, with chemistry. Biochemistry. Biology is the study of